Today we are going to start with the next chapter, that is rigid body dynamics, or you can say rotational dynamics, right? So till now we didn't care about the sizes of bodies. We always thought like bodies are point sized, right? We didn't care about the sizes, and we found the acceleration, velocity, etc., etc., considering that they are point sized. Okay, but now we'll think about the sizes of bodies. So now, what is a rigid body? So rigid body is a body whose shape and size does not change due to the applied force. Okay, so you exert some force, then it will only change the motion of body and it will not change its shape or size. Okay, so that kind of body, this is an idealization, is known as a rigid body. Okay, so now suppose this is one rigid body and it's moving with velocity v. Okay, this rigid body is moving with velocity v. So then what does it mean? So suppose there are n number of particles within this body, so all of the particles must be moving with velocity v. It can't happen that some particles move with velocity v, or let's say v1, some particles move with velocity v2. Why it can't happen? Because then some particles will move ahead and some particles will be left behind, and because of that the shape of body will change, and then our definition becomes wrong, that it's a rigid body. Okay, for rigid body shape will not change. So all particles must be moving with same velocity. Okay, in order that this body would be a rigid body. Then if body is rotating, then all particles within the body must have, okay, similar to this case, they must have same angular velocity. Okay, all particles must move with same angle theta in same time t, in the time t, right? Otherwise the same thing happens, that some particles will move ahead and some particles will be left behind and body will get distorted. Okay, so that thing won't happen. So we'll consider that velocity of all particles, if they are moving in straight line motion, it is same, and the angular velocity of all particles must be same. Okay, if they are moving in angular motion, that is rotational motion, right? Now after that, suppose I throw this pen like this towards you. Now it will not reach you, okay, but suppose I throw this pen in space. So the motion of this pen would be something like this. Okay, it will move like this, right? So we studied earlier that if you throw some object in space, then its motion is projectile motion, but this is not a projectile motion if object moves like this, right? So then which is that point of the body whose motion can be called as projectile motion? So that point we are going to study about that point. So that is known as center of mass. Okay, so we can say that there is a point of body where whole mass of the body is concentrated, and then if we are studying the effect of external force, then we have to study motion of that point only. Okay, so that point is known as center of mass. So when pen is thrown in the space, in which point moves in projectile motion? Only the center of mass will move in the projectile motion. Okay, and suppose this is a pan, right? This is a pan which rotates. So blades, these are the blades of fan. So different points, they will move with different velocities and they perform circular motion, right? But there is only one point of the fan, it will perform purely rotational motion, and that is the center of mass. Okay, so now what is center of mass? So let's define center of mass. So suppose we have two particles just like this, okay, and they are kept on x-axis. Okay, so we are going to consider only distance between them, right? So this is x-axis, this is y-axis. Okay, so now mass of first particle is m1, mass of second particle is m2. m1 is kept at some distance from origin O, m2 is kept at some distance x2 from origin. Then the center of mass, now because there is only one coordinate axis here, okay, on which these masses are kept. So center of mass xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Okay, so if we have two masses, then their center of mass is just xcm. X coordinate of center of mass would be m1 x1 plus m2 x2 divided by m1 plus m2. So this is very simple, right? Then now if you have n number of particles, this definition can be extended. So it will be plus m3 x3 m4 x4 so on and so forth up to mn xn divided by m1 plus m2 plus m3 so on and so forth up to mn. Okay. Alright. So now after that, the definition of center of mass in 3 dimensions. So for 3-dimensional system, we'll have 3 coordinates x, y and z. Okay, and how do we represent position of a particle? Using a vector called as position vector. So suppose these are my n number of particles having masses m1, m2, m3 so on and so forth. Then the position vector of first particle is suppose r1 bar, position vector of the second particle is suppose r2 bar, then so on and so forth. I can define position vectors of n number of particles. Then the position vector of the center of mass is given by this formula, m1 r1 bar plus m2 r2 bar plus so on and so forth up to mn rn bar divided by m1 plus m2 plus m3 so on and so forth up to mn. Okay, then okay, so suppose this is a body containing n number of particles, then I can say that total mass of this body is just sum of the masses of these particles, m1 plus m2 plus m3 so on and so forth up to mn. So total mass is suppose capital M. So I can write the denominator as capital M. Okay, so now we have defined the center of mass in this way. Now let's see what is the effect of this thing, okay, or what is the significance of this thing. That means significance of center of mass. So center of mass of a body can be represented like this. As we said, it is m1 r1 bar plus m2 r2 bar plus so on and so forth up to mn rn bar divided by mass of the body. Now take mass of the body on this side, okay, then you get mass multiplied by position vector of center of mass is equal to m1 r1 bar plus m2 r2 bar plus so on and so forth up to mn rn bar. Then you take one derivative of this with respect to time. So when you take a derivative of this thing, now considering that this is a rigid body, its shape, size will not change, so its mass will remain constant, right? So you can move the mass outside, the body will not break. Okay, if it is rigid means it will not break. So you can move the mass outside. Then you can take just position vector of the derivative of position vector of the center of mass. Okay, so derivative of position vector dr by dt is what? It is velocity. Okay, so similarly on right hand side you can take derivative of position vectors and it will give you velocities of all those particles. Okay, for an example, if you take derivative of this term, so m1 can be taken out, then you get dr1 bar by dt. So this is v1 bar. Okay, we know v is dr by dt, right? So then you get mass of body multiplied by mass of body multiplied by velocity of center of mass is equal to mass of first particle multiplied by velocity of first particle plus mass of second particle multiplied by velocity of second particle plus so on and so forth up to plus mass of nth particle multiplied by its velocity, right? Now what is mass times velocity? It is momentum. So if you add up momentum of all particles within the body, then what do you get? You should get total momentum of body, right? But what do you get? You get mass of the body multiplied by velocity of center of mass. Okay, so this tells you that we can consider that mass of the body is concentrated at center of mass, right? This tells you the mass of the body can be thought of as concentrated at the center of mass. This thing is clear? Yes, no? Okay, good. Then now we have sum of momenta of all particles, momentum of each and every particle. If you add it up, then you get mass of the body times velocity of center of mass. Then now you take another derivative with respect to time, then what do you get? So you get, again, mass we can move outside, it is just dv by dt, right? So mass multiplied by derivative of velocity with respect to time is acceleration. So you get mass of the body multiplied by acceleration of center of mass is equal to mass of first particle multiplied by dv1 bar by dt, that is acceleration of first particle. So m1 a1 bar plus m2 a2 bar plus so on and so forth up to plus mn an bar. Okay. So what is this thing? So we know that mass times acceleration is force, right? So this is the force acting on the first particle. Okay, mass of first particle times its acceleration is the force acting on first particle. Similarly, mass of second particle times its acceleration is force acting on second particle. So if you add it up, then what do you get? You get total force acting on the body, right? You get total force acting on the body. So now this F1 bar, the force acting on first particle, it can be of two types. It is sum of internal force and the external force, right? It is sum of internal force, means force due to other particles within the body acting on the first particle, plus force due to some external agency. Okay, so what is the total force acting on first particle? Part of it can be internal, part of it can be external, right? So we'll say that it is F1 internal int plus F1 external. Similarly, for second particle also, F2 internal plus F2 external, so on and so forth up to Fn internal plus Fn external, and this is mass of body times acceleration of center of mass. Then now this thing can be written as sum of all internal forces acting on all particles plus sum of all external forces, right? Sum of all internal forces, okay, internal force on first particle plus internal force on second particle, so on and so forth up to internal force on nth particle. So sum of all internal forces plus sum of all external forces. Then sum of all internal forces would be equal to 0, right? So why is this? Why is it so? The reason is, see, if you consider these two particles, okay, first particle, second particle, and you can think of any force acting between these two particles within the body. Okay, so according to Newton's third law, these forces would be equal and opposite. Let's say, for an example, there is a gravitational force of attraction between these bodies. Okay, so first body, second body will attract first body, and first body will attract second body with a force that is equal and opposite. So if you add it up, then what's the result of it? It is 0. Right? So similarly, it can be force of any nature. Sum of all forces, sum of all internal forces would be equal to 0. Right? And therefore, what is mass of the body times acceleration of center of mass? It is just sum of all external forces. Okay. So the total external force acting on the body, we learned till now that it is mass of the body times acceleration of body, but now we know that it is equal to mass of the body times what? Acceleration of which particle? It is acceleration of the center of mass, right? It is acceleration of the center of mass. So this gives you another reason to imagine that total mass of the body can be thought of as concentrated at the center of mass. Okay, we can think of total mass of the body to be concentrated at the center of mass, right? Because total force acting on the body gives you what? If you consider a point sized body, then it is force is equal to mass times acceleration. Okay, mass of that particle times acceleration of the particle. But for a rigid body, okay, however big it is equal to mass of the body times acceleration of which particle or which point? Acceleration of the center of mass. And therefore we can say that mass of the body is concentrated at center of mass. So this thing is clear, everyone? Yes, no? Right? Okay, good. So then, what is center of mass? It's the point at which the total mass of the body is supposed to be concentrated, and its motion is described by the net external force acting on the body. Okay, its motion is described by net external force acting on the body. So that means if external force acting on the body is equal to 0, then this acceleration would be equal to 0, right? If net external force acting on the body is 0, then acceleration of center of mass will remain 0. Okay, so if center of mass was at rest, it will remain at rest. If it was moving with some velocity, constant velocity, it will keep on moving with the constant velocity, right? So now this helps us to understand motion in simpler manner. So for an example, suppose you have this bomb, okay, or some Diwali explosive, you can say. Okay, so you throw it in space. Okay, suppose this is a bomb thrown in space. So how will the motion of this bomb look like? It will be a projectile motion. So at this point, what happens is the bomb breaks into two pieces. Okay, one moves with velocity v1 in this direction. Suppose it has some mass m1. Another one moves with velocity v2 in this direction, right? But now the center of mass of these two, it will keep on moving in the same direction. Same direction means what? It will keep on performing the projectile motion. Why? Because the total force acting on the body is what? It's just the gravitational force, right? And under the action of this gravitational force, okay, which is downwards, the motion of the body would be projectile motion. And this breaking of the bomb, okay, or explosion of the bomb, it's because of what? It's because of the internal forces. It's not because of any external force. So external force is still the same, and that's why the body, or not the body, the center of mass will keep on moving in projectile motion, right? So the trajectory of the center of mass, it will just look like this. Okay, so this is an example. We can take several examples of this. So suppose this is some radioactive atom, and initially it was moving in x direction like this. Now at some point, what happens that it emits an alpha particle. What is alpha particle? Alpha particle is helium nucleus. So it emits an alpha particle. So now this atom doesn't remain the same, okay, because it emits an alpha particle. So its nuclear configuration will change. So this is the atom, okay, parent atom you can say, or parent nucleus, and it emits an alpha particle. So there will be some resultant nucleus. So it is called as daughter nucleus. So suppose alpha particle moves in this direction, daughter nucleus moves in this direction, but what about the center of mass? So again, this radioactive reaction, it's because of the internal forces and there is no external force involved. So the center of mass of these two will keep on moving in same direction. Okay, so this will be the trajectory of center of mass, right? Okay, so that's simple. Then this is a double star system. Now do you know what is double star system? Double star system means two stars, they keep on moving. Okay, they are isolated from the other bodies, you can say stars and planets, okay, in space, and they are far away and they keep on moving due to the mutual gravitational attraction between the two. Okay, so now just like moon revolves around earth, okay, moon revolves around earth because of what? Gravitational force. So these two stars, they have comparable masses, or you can say masses are almost same, so therefore they will keep on revolving about each other. Okay, so if you look at the trajectory, it's complicated. it seems like this. Okay, the two stars, they move like this, so it looks complicated, but then this is mutual force of attraction between them and there is no external force. Okay, and therefore what we can say is their center of mass just moves in this direction, okay, in a straight line, right? So this thing is clear. Now let's look at some problems based upon center of mass. So two particles of mass 5 kg and 10 kg respectively are attached to two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from 5 kg particle is nearly at distance of. So this is from NEET 2020, that means recent one, okay, not that old, and this is very simple, right? So you just want center of mass of these two particles. What will you do? Tell me, what will be the center of mass? Okay, this is simple, right? So suppose, see, you want center of mass from 5 kg particle, so you will keep 5 kg particle at the origin. Okay, so this is 5 kg particle. Let's say M1 is at origin and M2 is at some distance from M1. This is M2. So it is at the other end of rod. Other end means the length of the rod is 1 meter. So M2 is at 1 meter. Okay. So XCM is just equal to what? M1x1 plus M2x2 divided by M1 plus M2. Right. So now just put the values. So what is M1? M1 is 5 kg. What is X1? X1 is 0 because M1 is at origin itself, plus M2 X2. So it is 10 kg times X2 is 1 and divided by M1 plus M2 means it is 5 plus 10, that is 15. Okay, so answer is 10 divided by 15. How much is that? 2 by 3 means 0.66 meters, 0.66 recurrent will come. Okay, so that is 0.67 centimeters, you can say. Sorry, in centimeters it will be 67 centimeters, right? Okay, so this one was very simple. Okay, let's see next one. Three masses are placed on x-axis, 300 gram at origin, 500 gram at x equal to 40 centimeter and 400 gram at x equal to 70 centimeter. Then the distance of center of mass from the origin is. Tell me. Again, this is also similar to the earlier one. Okay, so the distances are given 40 centimeter, 300 gram at the origin. So XCM is just equal to M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3, and this is 300 gram, 300 times 0 plus second one is 500 gram, 500 times 40 plus third one is 400 gram, 400 times 70. Okay, so that is 300 plus 500 plus 400, 300 plus 500 plus 400, and you just have to solve that. Okay, so that is how much is that? This is 800, 800 plus 400 is 1200. So in denominator you have 1200, and this is 2000, it will be 20,000, right? 20,000, and this thing is 28,000. Okay, so that is 48,000. So 48,000 divided by 1200. Okay, so that is 4. or did I miss a point somewhere? $500 times 40 is 20,000 and this will be 28,000. That's correct. So 40, not 4, 40. 40 centimeters, right? This is the answer. Okay, that's very simple. Right, it is just calculation. Okay, then let's see next one. Two bodies of mass 1 kg and 3 kg have position vectors, this one and that one respectively. The center of mass of this system has a position vector. So again, this is similar to the first two. So R bar would be just equal to M1 R1 bar plus M2 R2 bar and divided by you have M1 plus M2. Okay. So then it is M1 is 1 times of I cap plus 2j cap plus k cap plus you have M2 times. So M2 is 3 times minus 3 I cap plus minus 2j cap plus k cap, option A. Let's check. So 1 plus 3 is 4 and that is 1 and this thing is 3 times minus 3 is minus 9. Okay, 1 minus 9 is minus 8, minus 8 I cap plus this thing is 2 times minus 2 is minus 6. So 2 minus 6 is minus 4 j cap plus k cap plus 3 times k cap is 4 times k cap and everything divided by 4. That is minus 2 I cap minus j cap plus k cap, right. So it is option A. Okay. So again calculation, but these kind of problems are, they have been asked, right. Okay, so there is nothing in these problems, right. So this is just like warming up. Let's see next one. Consider a system of two particles having masses m1 and m2. If the particle of mass m1 is pushed towards the center of mass of the particles through distance d, by what distance would be the particle of mass m2 move so as to keep the center of mass of the particles at the original position? Okay, so there are two particles and you are moving one of them towards the center of mass by distance d. Okay, first one is moved by distance d. Then by what distance should you move the second particle also so as to keep the center of mass at the same position? This is the question, right? And it is not at all difficult. Okay, so now let's suppose that center of mass is at origin. Can we say that? We can say that there is no problem. Okay, so this is the center of mass, it's at origin. This is first particle, its mass is m1. This is second particle having mass m2 and this distance is suppose x1, this distance is x2. Okay, now what is center of mass? So option B. Yeah, that's correct. Okay, so let's check. See, center of mass is x coordinate of center of mass is 0. So that means m1 x1 plus m2 x2 divided by m1 plus m1 plus m2 is equal to 0, right? Then now what you are doing is you are pushing this particle towards the center of mass. So you are pushing the first particle towards the center of mass and you have moved it by distance d. This is the distance, and now because you have moved the first particle, the center of mass will change, but then you will also move the second particle, okay, so as to keep the center of mass at the same position. Now in what direction do you need to move it? actually you will need to move it in other direction. Okay, but you can find out in what direction you need to move it, right? So see, now what would be the position of first particle? So you can say that it is x1 minus d. So m1 x1 minus d, okay, plus m2, let's suppose you are moving m2 by d dash, okay, m2 by d dash, right? So m2 times x2 plus d dash, okay, because the distance of first particle will decrease, distance of second particle will increase, okay, divided by m1 plus m2, and you want to keep it at same position, so you can say it's equal to 0. And then you have m1 x1 plus m2 x2 is equal to 0. That means this m1 x1 plus m2 x2 will give you 0, right? You can move m1 plus m2 on other side, no problem. So that thing multiplied by 0 is still 0, and m1 x1 plus m2 x2 is 0. That means what remains is minus of m1 times d plus m2 times d dash, and that should be equal to 0. And therefore what's d dash? So move m1 times d on other side, it becomes positive. So m2 times d dash is equal to m1 d, and now move m2 on that side, so d dash is equal to m1 divided by m2 multiplied by d, right? m1 upon m2 times d. Okay, so answer is option B. So this is okay, this is also simple, right? So did you solve this way, Yamini, or something else? Same. Okay, now see, for simplicity we have considered that center of mass is at origin, and you can think of center of mass can be anywhere, right? It need not be at the origin. But then what will you say? The position vector of center of mass or position of center of mass remains same. Okay, the same problem can be solved in this way also. You need not think that center of mass is at origin. So this will be xcm, and you want to keep xcm same. Okay, xcm is same. So for that, this thing will be equal to what? Okay, its origin. See, this thing will be equal to what? xcm, which is m1 x1 plus m2 x2 divided by m1 plus m2, and that thing will get cancelled out. Okay, if you just substitute for that, what will happen? m1 x1 plus m2 x2 divided by m1 plus m2 on left hand side would be just equal to, because you want position vector of the center of mass or position of the center of mass to be same, right? So this will be equal to that, and again this thing will get cancelled out. m1 x1, m1 x1, m2 x2, m2 x2, it will get cancelled out, and you will get the same thing. Okay, this thing is clear. Right? So it can be solved in two ways. Actually it's the same way, but in first case we considered that position vector, the position of center of mass is 0. Okay, its origin. Okay, all right, it's simple. Let's see next one. Two persons of masses 55 kg and 65 kg respectively are at opposite ends of a boat. The length of the boat is 3 meter and it weighs 100 kg. The 55 kg man walks up to the 65 kg man and sits with him. If the boat is in still water, the center of mass of the system shifts back. This is the question. So this is a famous question. Okay, they kept asking it in different exams, right? So this is a boat in still water. Okay, boat is in still water. Right, and then this man walks up to the other man. Mass of first man is 55 kg, mass of the second one is 65 kg, and then this man, they are sitting at the two ends of the boat, but this one walks up to this man and sits with him. Okay, then what will be shift in the center of mass? Tell me, anyone?
It will be 0, sir.
It will be 0. Why will it be 0?
Yes, sir. There is no external force, so there is no shift in the center of mass.
Because there is no external force. Very good. So there is no external force, and that's why the center of mass will not shift. Don't you think if this man walks to this man, then the more mass will be on right hand side? Okay, can you counter this argument? Anyone? If this man is walking to the other man, then more weight will be on right hand side. So the center of mass should shift on right hand side. Anybody? How will you counter this? That's correct. Okay. There will be no change in the center of mass. But how? What will happen? Okay. So answer is simple. See, what happens is you have this boat, okay, and this man, suppose he walks, then in order to walk, what will he need to do? He pushes the boat in backwards direction, then boat pushes on him in forward direction, and he walks on the other end. And because of that, what happens is there is a force on the boat in backwards direction, and the boat itself will shift, right? So earlier, suppose the boat was over here, it was at position 0, so it will shift little bit backwards, you can say. Okay, so boat shifts in this direction, and weight of this and this person, it shifts towards right, and it happens in such a way that change in position of the center of mass would be 0. Right, this thing is clear. So this is a simple problem. Now we don't need to go in those details in the exam, right? So in exam we'll stop our thinking at that point, that net external force is equal to 0. So therefore there is no acceleration of center of mass. Okay, so center of mass will remain same at the same position, right? So its velocity was 0 earlier, and because there is no net force, therefore no acceleration, that means velocity will remain 0. Okay, so no problem. Let's see next one. Two particles which are initially at rest move towards each other under the action of their internal attraction. If their speeds are v and 2v at any instant, then the speed of the center of mass of the system will be. Okay, tell me. It will be 0. Okay, that is correct, right? Again, this is mutual attraction between particles. So this is first particle, this is second particle. They are moving towards each other with velocities v1, v2. Okay, and this is because of the mutual force of attraction. So if you think of these two particles as one system, then net external force on this system is also 0, and therefore acceleration of the system is 0. So earlier the two particles were at rest. Okay, as a system, the system was at rest, then the system will remain at rest, right? That means center of mass of the system will remain at rest. Okay, so otherwise in some other example, suppose this mutual attraction is not given, then you will just find out the velocity of center of mass as m1 v1 plus m2 v2 divided by m1 plus m2. Okay, so that is simple, right? Let's see next one. Three bodies having masses 5 kg, 4 kg and 2 kg is moving at speed of 5 meters per second, 4 meters per second and 2 meters per second respectively. So it is like that. Along x-axis, then the magnitude of velocity of center of mass is. So this is very simple. Okay. So velocity of center of mass is just equal to m1 v1 plus m2 v2 plus m3 v3 divided by m1 plus m2 plus m3. Okay, and that's equal to m1 is 5 times 5, right? First one moves with 5 meters per second plus 4 times 4. Second one having mass 4 moves with 4 meters per second, and third one having mass 2 kg moves with 2 meters per second, and in denominator you have 5 plus 4 plus 2. So that is 11 in the denominator, and this is what? 25 plus 16 plus 4, that is 20. So 45 divided by 11. 45 divided by 11, nearly 4, right? 4 meters per second. That's the answer. Option B. Okay, so that's very simple, right? So if there is an example like this or problem like this one or the one that was asked in 2020, that's very simple, right? Let's see next one. A block of mass m slides with velocity v along a frictionless level surface towards a block of mass 4m initially at rest. The velocity of center of mass is. Tell me. Block of mass m slides with velocity v along a frictionless level surface. Okay. So these are two blocks. One moves towards second one and with speed v. Again, there is nothing in this question. Okay. So what is the velocity of center of mass? It's m1 v1, that's v, plus m2 times velocity of second one is 0 because second one is at rest, divided by m1 plus m2. Okay, so m1 is m times v plus 0 divided by m plus 4m. Okay, so it is 5m. So it is just mm gets cancelled, v by 5. So option A. Right, so this is very simple. Let's see next one. Two bodies of different masses of 2 kg and 4 kg moving with velocities 2 meters per second and 10 meters per second towards each other due to mutual gravitational attraction. Okay, so again the same thing. What is the velocity of center of mass? So again the velocity of center of mass is 0, right? So as I said, this has been asked in different exams. Okay, so they have just changed mutual attraction. Again, that board question was also similar to this one, right? So no external force, velocity of center of mass will remain constant, not 0. If it is something, it will remain constant. Okay, let's see next one. A man of 50 kg mass is standing in the gravity free space at the height of 10 meter above the floor. What happened? Why is it 0? Okay, two bodies of different masses of 2 kg and 4 kg moving with velocities 2 meters per second and 10 meters per second towards each other due to mutual gravitational attraction. Mutual gravitational attraction, no. What is the velocity of their center of mass? So suppose you have this first object, this is the second object, okay, and they start moving due to the mutual gravitational attraction, right? So the net force acting on them is equal to 0, right? Net external force is 0, and that's why velocity of center of mass will remain constant. Okay, so initially suppose you take two bodies, and then they start moving with the gravitational force. Okay, so initial velocity would be equal to 0. Why is the initial velocity of center of mass equal to 0? Okay, that's your question. Okay, so initially if you are taking two bodies, right, you have two bodies, okay, and then if it is given that they are moving with these velocities towards each other due to mutual gravitational attraction. Okay, so these speeds are because of mutual gravitational attraction only. Right? Yes, no? Yeah, so you will assume that they will start from rest. Okay, so see, if they give that two bodies are moving with some velocities, okay, so question can be framed like this also. First body is moving with 2 meters per second, second one with 10 meters per second in some direction. Okay, so you can find out initial velocity of center of mass, and then after some time these are the velocities of these two bodies. So what is the velocity of center of mass? Question is like this. Then you will say that the initial velocity of center of mass is the velocity of center of mass now, right? But they are saying that these velocities are because of the mutual gravitational attraction. That means these are because of the mutual gravitational attraction, okay, because of gravitational acceleration. So initial velocity would be 0, right? Okay, good. So this is also same question asked in different exam. There is nothing in this question also. Let's see this one. A man of mass, uh, a man of 50 kg mass is standing in gravity free space. At a height of 10 meter above the floor, he throws a stone of 0.5 kg mass downwards with speed of 2 meters per second. When the stone reaches the floor, the distance of man above the floor will be. Alright, so man is standing on in a gravity free space, okay, at height of 10 meter above the floor. So man is at the height of 10 meter above the floor. Man is at this height, right? This is 10 meters, and then he throws a stone. He throws a stone like this downwards with a speed of 2 meters per second. Okay, so speed of stone is 2 meters per second. When the stone reaches the floor means it covers a distance of 10 meters. Then the distance of man above the floor will be, okay, tell me. Anyone? Okay, so see, this is also simple. So you have thrown this stone downwards and there is no gravity, right? There is no gravity. That means now initial position initial position of center of mass is suppose at this position. Okay, so let's call this 0, right? So the stone, it moves 10 meters downwards, means the man will move suppose let's say x distance upwards, or let's say distance of man is x1 upwards and distance of the stone is x2 downwards. So if you say that this point is 0, then this 0 must be equal to what? m1 x1 plus m2 x2 divided by m1 plus m2 must be equal to 0, right? So m1 plus m2, this thing is 0, sorry, m1 plus m2 multiply with that 0, you get 0. Okay, so then put the values. What is mass of the man? It's 50 kg. So 50 times x1 plus mass of the stone is 0.5 multiplied by the stone moves downwards. Okay, so its distance covered is 10, right? So let's say minus 10 because it's downwards. Okay, so minus 10, so that's equal to 0. So this thing is 5, right? 0.5 times 10 is 5. So this is minus 5, move it on other side, it will become plus 5. So x1 would be equal to that 5 divided by 50. So that's 0.1. So the man who was here at this level, he will move distance 0.1 upwards. Okay, he will move upwards by distance of 0.1 meters, right? And therefore what will be the distance of the man above the floor now? So earlier it was 10 meters, now it will be 10.1. Okay, this thing is clear. Okay, so now we studied the center of mass of bodies having discrete masses. Okay, means particles having discrete masses. Suppose there is a system like that, you can find out center of mass using this formula. What formula? Position vector of center of mass is m1 r1 bar plus m2 r2 bar plus so on and so forth up to mn rn bar divided by m. So if you have countable number of particles, okay, or countable number of masses within the body, then you can find out center of mass using that way. But then in real life the bodies are continuous and we cannot say that there are n number of particles in the body. Okay, at least we can't count the number of particles, and therefore we consider that mass is continuously distributed all over the body. Okay, and therefore now we have another method to find out the center of mass. So what we say is, what we do is we break this body into n number of small segments as shown here. Break means we imagine this body to be made up of these small segments, okay, small pieces having mass dm each. Okay, so we can define density of the body. Density is mass divided by velocity. So dm would be equal to what? Rho times dv. What is dv? dv is the volume of one such part, one such piece. Okay, then now suppose this is the position vector of this small mass dm. Okay, from the origin it is suppose r, it is r bar. Okay, there are n such masses, so their position vectors will be r1 bar plus r2, r1 bar, r2 bar, r3 bar, so on and so forth. So then how to find the center of mass in such a way. So you will name these particles, okay, dm1, dm2, dm3, okay, their position vectors are r1 bar, r2 bar, r3 bar. Then you will add it up, dm1 times r1 bar plus dm2 times r2 bar plus dm3 times r3 bar, so on and so forth up to dmn times rn bar, and divided by mass of the body. So you write that in compact form using the summation dmi times ri bar, okay, you sum it over I goes from 1 to n, I from 1 to n, right? So this is how we write it in compact form. So now we know that if number of such pieces goes to infinity, then what happens to the summation? It becomes an integral. Okay, what happens to the summation in that case? It becomes an integration. So we saw this in mathematical methods and quite a few problems after that, right? So summation becomes integration if it is a continuous addition, right? And if n tends to infinity, we can say n becomes infinity. So therefore the position vector of such a body can be written as integration of dm times r bar upon m. Okay, m is total mass of the body. Then we can write the position of x coordinate would be equal to integration of dm times x by m, position of y coordinate would be dm times integration of dm times y by m, and position of z coordinate would be integration of dm times z divided by mass of the body, right? So that's how we find the center of mass. So now we can see an example of this. So suppose you have a pen like this, and suppose this is uniform pen, means its thickness is uniform and its density is uniform. Then what do you think, where should be the center of mass of this one? It should be at the center, at the midpoint, right? Okay, so you can find it out using this method. So see how, suppose this is my pen and I want to find out its center of mass. So what I will do is, this is a linear body, so I will define its linear mass density, mu is equal to its mass divided by length. Okay, mu is equal to mass divided by length. Then now suppose I take small piece of this pen, so dm is the mass of that piece, so mu would be, for this piece I can write mass upon length is dm divided by its length is dl. Okay, so dm is equal to, this mass is equal to mu times dl, just move this dl on other side. Okay, so after that, now if I want to find out x coordinate of center of mass, and there will be only one coordinate, okay, because this is linear body, so I can say that this mass is at length L from the center means from the origin. Okay, so I can integrate this. Okay, what will be x coordinate? X times dm, integration of x times dm divided by m. So what is x? It is this length. Okay, it is at distance L from the center, from the origin. It is integration of L times dm divided by its mass. Okay, and what is dm? Dm is just mu times dl. You put that and you integrate it from 0 to L. Okay, then you can move mu outside and you have m in the denominator. So integration of L dl is just L square divided by 2. Okay, so this thing is just L square divided by 2, right? And then you put value of mu, so mu is m upon L, so you put it over here, m upon L, lower limit is just 0, so you need to take L square by 2 only. Okay, so you have this m in the denominator, you put mu is equal to m upon L, so m gets cancelled out, 1 L from the square gets cancelled out, and as we anticipated earlier, this is just equal to L by 2. Okay, just equal to x coordinate of center of mass, it is just equal to what? L by 2, right? Okay, this thing is clear? Yes, no? So this is the method to find out the center of mass of continuous objects. So now I explained this problem just to understand this method, okay, and we don't need to do this in exam, but we should be able to do if there is such a need, okay. So then we can take several such examples, okay. Then let's see the center of mass of semicircular ring. So again we can solve it in the same way. So here there will be two coordinates. Why? Because this is a planar object, this is not a linear object, right? Okay, it's a ring, means it is circular, okay. So if you take full ring, then your intuition will tell you that its center of mass will be what? Just its center, okay. If you take a ring, its center of mass will be just its center. Then for this ring, which is semicircular, now what will be its center of mass? So you can just say, okay, if you draw a vertical line, you can say that its mass is symmetrically distributed about that vertical line, right? So that means x coordinate of the center of mass must be 0, right? X coordinate would be 0 because from origin the mass is equally distributed towards left and towards right. So x coordinate has to be equal to 0, okay. And then you just need to find out the y coordinate, okay. So now we solve it using the same method. So what we do is we take again a small piece of that, okay, it is at distance of r from the origin. Then you find the x coordinate of the small piece, you find the y coordinate of small piece, okay. And suppose it is at angle theta. So we know that x would be equal to r cos theta, y would be equal to r sin theta, okay. And then the theta will change from what? It will change from 0 to pi, okay. This is 0, it will change from 0 to 180 degrees, from 0 to pi, okay. So in same way we find it out, we integrate what? X dm from 0 to pi, okay, and we divide it by m, so we get the x coordinate. In similar way we find the y coordinate, we integrate y dm from 0 to pi, right? Angle will change from 0 to pi and we divide it by m. So the x coordinate comes out to be equal to 0, okay. Y coordinate, just remember this, it comes out to be equal to 2r by pi, right? This thing is clear? Yes, no? Okay, the method is same, we just need to put x is equal to r cos theta and theta will change from 0 to pi, that's it, okay. Similarly y is equal to r sin theta, theta will change from 0 to pi, okay. So I can explain that, but it needs some time, but the method is clear how to find it out, right? So just remember this final answer, okay. This is clear? Yes, no? Right, good. So y coordinate of a semicircular ring is 2r by pi, okay. So there might be a question, maybe very few chances are there, but let's remember this, okay. After that let's talk about the linear velocity and angular velocity, okay. So this thing completes the center of mass. Now there would be, for symmetric bodies, the center of mass is what? It is at just the geometrical center, okay, geometrical center. So using symmetry we can find out the center of mass of bodies, okay. All right, let's see next thing. So let's discuss the linear velocity and angular velocity. So we have discussed it a little bit in circular motion, right? So now suppose we have a laminar body. Laminar body means a body which can lie in a plane. So for such a body, okay, now thickness doesn't matter. So let's suppose this is point P of this body and the body is rotating like this about the axis which is passing through its center, okay. So it's rotating about this axis. So this is the angular velocity, omega bar, Okay, so we remember how to find the angular velocity using what? The right hand thumb rule. So suppose body is rotating like this, then we'll call our fingers of the right hand in that direction, in the direction of rotation, and we'll stretch the thumb. So stretched thumb gives the direction of angular velocity. Okay, and we know this v is equal to r times omega from circular motion, right? So if you want to see the vector relation would be equal to v bar is equal to omega bar cross r bar for this laminar body. Okay, v bar is always equal to omega bar cross r bar. So now suppose this is origin, this is vector r bar, okay, and v bar would be tangential at that point, means it will be into the plane of the board. Okay, if this is vertical, this is horizontal, it will be v bar would be into the plane of the board, right? So then you can try doing omega bar cross r bar, whether it gives you the direction of v or r bar cross omega bar. Okay, so I am saying that omega bar cross r bar will give you v bar, okay, the correct direction, right? This thing is clear? Yes, no? Okay, so this is relation between linear and angular velocity. Now this is true for a laminar body. Now if you have a body something like this, okay, right? So then now you will define some origin. So this is suppose the origin of body, okay. Then now you will need to define the position vector of all particles using this origin, okay. So now what I can do is this r bar I can resolve into two components. So this is my axis of rotation. I can say this is r parallel and this is r perpendicular, right? This r bar can be written as addition of this one and this one, r parallel plus r perpendicular, okay. So then now r parallel is parallel to omega bar, r perpendicular is perpendicular to omega bar. So now if you take cross product of omega bar and r bar, what do you get? So omega bar cross r bar is equal to omega bar cross of r parallel plus r perpendicular, okay. So then what is omega bar cross r parallel? So you just break this bracket, okay, split the bracket. So omega bar cross r parallel plus you have omega bar cross r perpendicular, right? So omega bar cross r parallel is equal to 0, right? Omega bar cross r parallel is equal to what? 0. This thing is clear because they are in same direction, and we know that cross product means vector product has magnitude of what? Magnitude of first vector into magnitude of second vector multiplied by sine of the angle between two. And what is angle between this omega and r parallel? The angle is 0, right? Yes, no? Okay, so that angle is equal to 0, okay, and therefore you have omega multiplied by r parallel multiplied by sine 0. Sine 0 is 0, so therefore this term will vanish, and what will you have? Omega bar cross r bar is just equal to omega bar cross r perpendicular, okay, and therefore now you can say v bar, the velocity of this particle, it's like this. So you have omega bar, if you take omega bar cross r perpendicular is equal to v bar, right? You can always say that, yes, no. If you take that plane, if you take this circle only and you forget about remaining body, okay, so then omega bar cross this r perpendicular will give you v bar, just like this previous case, right? Okay, therefore now v bar is equal to omega bar cross r perpendicular, but I can also write it as v bar is equal to omega bar cross r bar, because r bar will contain what? R parallel and r perpendicular. If I take cross product of omega bar with r parallel, it turns out to be equal to 0, right? So I can always write that V bar is equal to omega bar cross R bar. Is this thing clear? All right. So after that, let's talk about next quantity. Now this will come like discrete terms. Okay. But this is just, you can say, foundation. Okay. All right. So next thing is torque. So what is torque? Let's understand torque. So just like we have force in linear motion, we have torque in rotational motion. Okay, so what does it mean? For an example, suppose you have this door, this is door of your room that you are sitting in right now, and you want to open it, or if it is open, you want to close it. Then now the door will rotate about this axis, okay, which passes through its hinges, right? The door rotates about the axis which passes through the hinges. Then now where do you need to apply the force in order to rotate it? You want to rotate the door, where will you apply the force? At the hinges you can't apply, right? At this end you can't apply it, you need to apply it at the other end. Okay, so the handle is always at the other end, you can see that. And if you move the handle closer, I mean handle is not here, and if it is here, it will be very difficult to open it and close it. Okay, you will need to apply greater force, right? This thing is clear. So you want to rotate the door, this rotational action will depend on what things? It will depend on the position at which you are applying. It will depend on the position at which you are applying the force. It will depend on the force that you are applying, and it will also depend on the angle between this position and the force, right? It will depend on these three things. Okay, is this thing clear? For an example, suppose I have this book, okay, and suppose this is the door, right? I want to rotate it. Okay, this is very big one. Let's say I want to rotate this one, so I need to exert force at this end. Okay, I can't exert the force here. If I exert the force, see, this is very weak kind of an object, still I am exerting a force here, it's not rotating at all. It might break, but it will not rotate. Okay, so this thing is clear? Yes, no? So this is the hinges at this end. So if I exert the force away, it becomes very easy to rotate it, right? So R is important. R is distance of the force from the axis of rotation, you can say. But you can consider any origin, and you can take the perpendicular distance from that origin. So that is your R, right? Then F is the force that you apply. Okay, more the force is applied, more will be the rotational effect. Okay, and then theta is the angle at which you apply it. Okay, you see, I am applying it perpendicular to R, then it rotates very easily. If I apply it parallel to R, okay, I am applying force parallel to R, is it rotating? Not at all rotating, right? This thing is clear. If I pull it in this way, R is in this direction, parallel to R, if I exert the force, it doesn't rotate. Okay, so the angle is also important. So it tells you that the rotational effect, so rotational effect of a force is called as torque, or it is also called as moment of force. It is also called as moment of force, and this moment of force, torque, it is equal to R times F times sine theta. Okay, it is R times F times sine theta, right? Now this thing is clear. If angle is 0 or 180 degrees, then rotational effect is 0, as I have shown you. Okay, as I showed you right now. Okay, so if angle is 0, rotational effect is 0. Its maximum when angle is 90 degrees, and we know sine of 90 is maximum, sine of 90 is 1. Okay, So that means this rotational effect depends on r, it depends on f, and it depends on sine of the angle between r and f. Okay, and therefore it must be what? The cross product of r and f. Okay, so torque, we denote torque by this letter tau. So tau bar is the torque due to the force F acting at position vector r bar. Okay, so it is r bar cross f bar. Okay, this thing is clear, everyone? Right, good. Then good. Again, let's see next term, which is the angular momentum. Now what is angular momentum? So we'll just define the angular momentum. Angular momentum of one particle about any origin. Okay, so you can pick some origin. Let's suppose here, what is the angular momentum of this particle? So particle moving this way, okay, so momentum can be written as m times v bar. So at the moment the position vector of the particle is r bar, then its angular momentum is just r bar cross p bar. What is angular momentum? It is r bar cross p bar. Right, what is angular momentum? R bar cross p bar. Okay, and this quantity now it might seem to you meaningless or maybe of not much importance, but it comes out to be very important in case of rotational motion. We'll see that. Okay, so angular momentum is r bar cross p bar. Okay, then it is called as moment of linear momentum, because just like we had moment of force r bar cross f bar, okay, it is r bar cross p bar, right, r bar cross p bar. So if you have r bar cross position vector cross product with any term, it is called as what? Moment of that term. Okay, so this is moment of linear momentum. And then if you take the derivative of this thing with respect to time, if you take derivative of L bar with respect to time, then what do you get? What is L bar? L bar is angular momentum. So you get d by dt of r bar cross p bar. Okay, so d by dt of r bar cross p bar is, using the product rule, it is dr bar by dt cross p bar plus r bar cross dp bar by dt, right? Then what is dr bar by dt? It is rate of change of position with respect to time. So it's velocity. Okay, it is velocity. So then you have velocity cross momentum is mass times velocity, okay, plus you have r bar cross dp bar by dt. So using Newton's second law, this is what? Force. Okay, dp bar by dt is force, right? So you have this first term v bar cross m times v bar, and the cross product of same vector or vector with itself, right, it is equal to 0. We know that, because it is magnitude of this one times magnitude of this one times sine of the angle between two. So this thing is 0. Okay, what remains is r bar cross f bar only. So we have rate of change of angular momentum is equal to r bar cross f bar, and then it's equal to what? Torque. Right, this thing is clear. For one particle we have proved that rate of change of angular momentum, that means rate of change of r bar cross p bar, is equal to torque. Okay, torque acting on that particle, because r bar cross f bar we have just seen that it's equal to torque. Okay, this thing is clear. Is this thing clear, everyone? Right. So then now we'll see afterwards that this angular momentum is related to angular velocity of a body. Okay, we'll see that. So just like we have Newton's second law for the linear motion, that f bar is equal to what? Dp bar by dt, rate of change of linear momentum with respect to time. Just like that, we have torque is equal to dl bar by dt. So for now we have seen this for one particle. Okay, for now we have seen this thing for one particle. We'll see this for a rigid body too. Okay, but it will come out to be the same. Torque acting on the rigid body is equal to what? Rate of change of angular momentum of rigid body with respect to time. Okay, and this thing is called as the Newton's second law in case of rotational motion. Okay, this thing is known as the Newton's second law for what? Rotational motion. Okay, so we'll see significance of this thing, right? So but this thing is clear that comparing this thing with this thing, we can say that this is torque is analogous to force and angular momentum is analogous to linear momentum. Okay, so state of rotational motion of a body is defined by angular momentum. Okay, state of rotational motion of a body is defined by angular momentum, and if torque acting on a body is 0, then the angular momentum of body remains constant. Okay, if torque acting on the body is equal to 0, then angular momentum of body will not change. That means now we'll see that angular momentum is related to angular velocity. Okay, so if torque is 0, angular momentum will remain constant, angular momentum will not change. So this thing is known as law of conservation of angular momentum. Okay, so I will state it in different way. So I am not relating right now, but I am just stating it that a body is at rest, it will remain at rest. A body is moving with constant angular speed, it will keep on moving with the constant angular speed if there is no external torque acting on the body. Okay, is this thing clear? Right? So right now I am not relating angular momentum with angular velocity, but we'll relate that afterwards. But right now I am just stating it. Okay, so this is law of conservation of angular momentum. Angular momentum of a body remains constant if torque acting on the body is equal to 0. Okay, all right. So right now let us just see some problems based upon these things. Okay, whatever we saw. All right, let's see this one. What is the value of linear velocity if r bar is equal to this and omega bar is equal to this? This is also from NEET. I don't know which year, but this is from NEET or AIPMT. So we know that v bar is equal to what? Omega bar cross r bar. Okay, so it is just ijk. We know how to find this cross product. I cap, j cap, k cap. Then you have omega x, omega y, omega z, which is 5 minus 6, 6, 5 minus 6, 6, and this thing is 3 minus 4, 1. What is the answer of this thing? Put I cap, take I cap, okay, then hide the column and the row containing I cap, and this thing multiplied by, with this thing. So minus 6 times 1, that's minus 6, minus 4 times 6 is minus 24. So minus minus plus, minus 6 plus 24, so that is 18. Okay, and that means I don't need to check any other option, it's option B, right? Okay, but let's find it out. Then minus j cap multiplied by 5 times 1 minus 6 times 3. So 5 minus 18, so that is minus 13, and minus minus becomes plus, so plus 13. Okay, plus you have k cap multiplied by 5 times minus 4 is 5 times minus 4 is what? Minus 20, minus 20 minus minus 18, right? That minus 18 on this negative sign, it becomes plus 18, minus 20 plus 18 is minus 2, so minus 2 k cap. So that is your answer, it's option B. Okay, because there was no 18 in any of the other options, we could just say that it is option B right there. Okay, this is clear. There is nothing in this one, very simple, right? Yes, everyone. All right, good. Let's see next one. Find the torque about the origin when force 3j cap Newton acts on a particle whose position vector is 2k cap. Okay, this is also from NEET 2020. We saw another question from NEET 2020 and it was very simple, right? So I guess NEET 2020 was very simple. Okay, but that is just fraction of questions. All right, so talk about the origin when force of 3j cap. Option C. Okay, let's check. So torque is equal to what? R bar cross F bar. That is position vector is 2k cap cross 3j cap. Okay, then 2 times 3 is 6. 6 times, is it I cap or is it minus I cap? Minus I cap, right? Yes, do you remember everyone? Yamini told the answer. How do we check that? So we put this I, J, K, okay, and this is I cap, J cap, K cap, and then we put the arrows from I to J, J to K, K to I. Then if I want to find out what? K cap cross J cap. So K cap cross J cap, I am going in opposite direction of arrow. So K cap cross J cap is what? Minus I cap. If I go in the same direction of arrow, then J cap cross K cap would give me what? I cap. Okay. Right, you remember this? Yes, no? Selva Kumar, Nikita?
Yes, sir.
Okay, good. So this is minus I cap because we are going in opposite direction of arrow. K cap cross J cap is minus I cap. Okay. Let's see next one. The moment of force F bar, this is F bar at 2, 0, minus 3 about a point 2, minus 2, minus 2 is given by. Tell me. So what does this thing mean? You have this point and you are calling this point as origin, or origin means, origin doesn't always mean 0, 0, 0. Okay, origin means what? The reference point from which, okay, about which you are calculating the things, everything. Okay, so you are calculating it about this point, so this becomes origin, right? But what is that point? So see, let's say this is that point, so let me call this thing as R1 bar. This is my R1 bar and this is my R2 bar. Okay, so this is the position vector of this point, and this one is position vector of this point. Okay, so what will be this thing? 2i cap minus 2j cap minus 2k cap, right? And for this one it will be 2i cap plus 0j cap minus 3k cap. Then what do I want is, I am exerting a force at this point, okay, at this point, and force is suppose in any direction. Let's say this is the force like this, and I want moment of this force. Okay, it acts at this point, but you don't want moment about the origin. If you wanted moment about origin, then you could just take what? R2 bar cross F bar. But now you want moment about this point. That means you need to take position vector of this point from this point, right? Okay. What are these points? This one is 2, minus 2, minus 2, and this one is 2, 0, 3. Okay, you want this position vector. So that is your R bar. Now you can find out what is R bar. So R1 bar plus R bar gives you R2 bar. That means R bar is equal to R2 bar minus R1 bar, right? Okay, so here I guess we found displacement, it's similar to that. Okay, but this kind of a problem we are seeing for the first time, that's why I'm explaining this. But suppose you want to find the torque of this force at this point, which is acting at this point, about this point, what will you do is you will just subtract position vector of this one from this one, and that is your R bar, right? So R2 bar minus R1 bar, and that is 2 I cap plus 0 j cap minus 3 k cap, okay, minus what's that, 2 I cap minus 2 j cap minus 2 k cap. So 2 I cap gets cancelled, you have minus plus, right? 2 j cap plus what's there, minus 3 k cap minus plus 2 k cap, so that's minus k cap. So you got the R bar, okay, you got the R bar. Then you just need to take R bar cross F bar. So what is force, what is torque? R bar cross F bar. So torque is equal to R bar cross F bar, and that is just equal to I cap j cap k cap, I cap j cap k cap, and what is R bar? Minus 2 j cap minus k cap. So this thing is 0, 2 minus 1, and force is 4, 5 minus 6. Force is 4, 5 minus 6. 4, 5 minus 6. So let's calculate that. Okay, whatever it is, that would be the answer. Okay, so let's calculate this thing. Tell me, it will be I cap multiplied by minus 12 minus plus 5, so 7 I cap, okay, minus j cap multiplied by, this thing will be 0 minus 4, so plus 4, okay, plus k cap times 0 minus 8, okay, minus 8 k cap. So this is the answer, 7 I cap minus 4 j cap minus 8 k cap. If my calculation is correct, 7 I cap, no, it should be minus 7, no, minus 7 I cap, okay, minus 4 j cap minus 8 k cap, and that is option C or D. Both are same? No, this one, option D, right? Yeah, so this is how we will solve this. This is just some calculation, nothing else. And this is from NTA, because it's 2018, right? So they can still ask question like this. This thing is clear? Yes, no? Okay, everyone? All right. So very simple. Okay, next one, a force F bar is equal to, this thing is acting on at a point R bar is equal to something, the value of alpha for which the angular momentum about origin is conserved is. Very simple, angular momentum is conserved means what? Torque acting is equal to 0, right? So L is conserved, L is constant, means torque acting is equal to 0, and then just find torque and equate it to 0, that's it. So nothing. So what is torque? R bar cross F bar, okay, that is R bar cross F bar is equal to 0. find out r bar cross f bar, do I j k, I cap j cap k cap, alpha, then you have 3, okay, then you have 6, and then you have 2 minus 6, okay, minus 12, and this thing should be equal to what? 0, but it is 0 vector, right? So if this thing is 0, that means you don't need to solve the complete determinant, all of its components are 0, right? So just take one component in which alpha will come. So I will just take the y component, or later just find it. Okay, let's find out what is this torque. Okay, so it is this thing times this thing means minus 12 times 3 is minus 36, and 6 times 6, okay, so that's minus 36 minus minus 36 means 0, so 0 I cap plus minus j cap times alpha times minus 12, so minus 12 alpha, okay, then you have 6 times 2, right, minus 12, okay, and then you have k cap plus k cap multiplied by minus 6 alpha, minus 6 alpha, minus 6 alpha, and what? Minus 6, okay, and that is equal to 0. So if this thing is 0 means x coordinate is 0, right? Sorry, what did I say? X coordinate, not x coordinate. X component is 0, y component is 0, z component is 0, right? X component 0, y component 0, z component 0. So minus 12 alpha minus 12 must be 0. So minus 12 alpha is equal to 12 if I take y component only. So minus 12 alpha is equal to 12. So alpha is equal to minus 1. That's the answer. Option C. Right, this is clear. Yes, no? Okay, so what I was saying at the beginning is just take one component in which alpha will come, because if torque is 0, its x component is 0, y component is 0, and z component is 0. So no need to solve this determinant completely, just take one component. So I was saying that just take j cap times minus 12 alpha minus 12 is equal to 0. So j cap times minus 12 alpha minus 12 is equal to 0, means this minus 12 alpha minus 12 is 0, right? So alpha is minus 1. Okay, is this thing clear? Yes, no? Right, so just find one component, equate it to 0, and you will get the answer. You don't need to solve for complete determinant. Okay, all right, let's see next one. When a mass is rotating in a plane about a fixed point, its angular momentum is directed along. Okay, tell me. Mass is rotating in a plane about a fixed point, its angular momentum is directed along. So let's say mass is, this is mass rotating in a plane. So you can say it's moving at this point, it's moving in this direction. Option A is line perpendicular to plane of rotation. Right, that's correct. Okay, so this is V bar. So imagine that this V bar is perpendicular to plane. Okay, that means it is into the plane of the board. So what is axis of rotation? Axis of rotation will be like this. It's a perpendicular line, and this mass is moving like this. So this is, suppose its position vector, right? R bar, this is R bar. So what is P bar? P bar is, question is what is angular momentum? So P bar is R bar cross P bar. So if you do R bar cross V bar, okay, that means towards right and into the plane of the board. R bar cross V bar, if you do, you will get upwards direction, that is perpendicular to plane of board. Sorry, perpendicular to plane of this rotation. I said board. Perpendicular to plane of rotation. Right? So that is option A. This is clear? Yes, no? Everyone? Okay, good. Let's see next one. A particle of mass m equals to 5 is moving with uniform speed of v equals to 3 root 2 in xy plane along a line y equals to x plus 4. Okay, speed is given, it's moving in xy plane or xy plane, you can say. Along this line, the magnitude of angular momentum of the particle about the origin is. What is the angular momentum? So let's say this is xy plane and the object is moving along this line. So y is equal to x plus 4, right? The object is moving along this line. So this is a good question. This is the line, suppose. And what is the line? Y is equal to x plus 4. So we get two things from this line. What do we get? What's given? Mass is given, right? Speed is given, and this line is given. The line along which it moves, it is given. So we can find out in what direction it's moving, right? So compare this thing with y is equal to mx plus c. Y equals to mx plus c. You get m is equal to what? 1 and c is equal to 4. Okay. That means if line is inclined at an angle of theta, then you have tan theta, m is equal to tan theta, m equals to tan theta, and that is 1. That means, theta is equal to 45 degrees, right? Because we know tan of 45 is 1. Okay, yes, no? This is clear? Okay, then we want angular momentum. So what is angular momentum? L is equal to, you can go step by step, r bar cross p bar, right? If you want its magnitude, L is equal to r, p is equal to what? Mass times velocity multiplied by sine theta. So theta is the angle between r and v. Okay, theta is the angle between r and v, and you know that this line v bar, it's making an angle of theta with the x-axis. Okay, but then now if particle is at this position, particle is at this position. Okay, so this is position vector, means it's along y-axis, right? Because if this is origin, then this is the position vector and this is velocity vector. Then at this point only you know what's the angle. So if this angle is 45, this angle must be 45. But then if particle moves here, then it will be difficult for us to find out the angle, because position vector will be directed like this. Okay, and velocity would be like this. Okay, so that means what should we do? We should take the position vector at start. So this is the position vector r bar. What is its magnitude? What is its magnitude? Can somebody tell me? R bar is directed like this. Yes, anybody? It is equal to, good, it's equal to 4, right? Because your equation is y is equal to x plus 4. So put x equal to 0, then you get y equal to 4. So at the beginning y is equal to 4. That means when x is 0, y is equal to 4. So the value of r is equal to 4, right? in this equation, in this equation, what is C? It's value of y when x is equal to 0. Okay, and you have C equals to 4. So that means value of y when x is 0, put x is 0, then what you get? Y is equal to C. C is 4, means y is equal to 4, right? So what is value of R? This R when x is 0, it is y, that is equal to 4. Okay, this is just equal to 4. So then you can find it out. What is the angular momentum? So it is 4 multiplied by, what's the mass? Mass m is equal to 5, right? 5 multiplied by what is speed? 3 root 2. 3 root 2, and sine theta means it is 45 degrees, so 1 by root 2. Root 2 gets cancelled. 5 times 4 is 20, 23s are 60. So 60 units is the answer. Okay, 60 units is the answer. Is this thing clear? Everyone? Right. So till now, what I think is this one was the best question, right? This one was a good question, and it's from 1991. Okay, but because it was a good question, I took it. Anyways, let's see next one. A particle of mass m moves in xy plane with velocity v along a straight line AB. A particle of mass m moves in xy plane with velocity v along a straight line AB. If the angular momentum of particle with respect to origin is LA when it is at A and LB when it is at B, then tell me angular momentum of the particle when it is at A is LA. It's moving in a straight line with speed v. Option A, right, LA is equal to LB. If no external torque acts on it, here there is no mention of force also. So if there is no force means there is no torque. So if there is no external torque acting on the particle, then angular momentum remains conserved. Okay, so LA is equal to LB is the answer. Right, this thing is clear, everyone? No torque means angular momentum remains constant, and therefore LA is equal to LB. Whether the particle moves from A to B or B to C doesn't matter. No force, so no torque, and therefore angular momentum is constant. Alright, next one. A small mass attached to a string rotates on a frictionless tabletop as shown. So this small mass rotates on this tabletop. If the tension in the string is increased by pulling the string, causing the radius of circular motion to decrease by a factor of 2. Okay, then the kinetic energy of mass will, tell me what is done. If tension in the string is increased by pulling the string, causing the radius to decrease by a factor of 2. Okay, the kinetic energy of mass will. Okay, so see here, you are pulling the string. So suppose this mass is moving in a circle and you are pulling the string and decreasing the radius. So in what direction are you applying the force? This is the tension. Okay, you are pulling the string, so tension is increased and you are decreasing the radius in that way. In what direction are you applying the force? In radial direction. So if I take radius vector, it will be directed like this. So what is the torque? it will be r times tension, because tension is the force here, times sine theta. And what is theta here? So r is directed like this, okay, position vector, and t is directed like this, so theta is 180 degrees, so sine 180 is 0, so rt sine of 180, okay, it is 0, and therefore torque is equal to 0. So there is no external torque acting on this thing, so angular momentum remains conserved, okay, and therefore r times p is constant, because, okay, so for a body or for a mass which is revolving in circle, angular momentum is just r times p. Why? Because the angle between r and p, r is along the radius, p means momentum is along what? Along the tangent, because velocity is along the tangent. So it is r into p multiplied by sine of 90, angle between radius and tangent is 90, right? Therefore sine 90 is 1, so it is always r times p. So L is constant because no external torque, that means r times p is constant, and r times p is constant means, so why are we doing this? R times momentum is constant because they are asking what is the kinetic energy, okay. So you are decreasing the radius, so you are decreasing the radius, r1 p1, you can say it's equal to r2 p2, you are decreasing the radius means the momentum will increase, right? So r2 is equal to what? It is, you are decreasing the radius, r1 by 2, so r1 gets cancelled, and therefore p2 is equal to, move 2 on that side, p2 is equal to, momentum is equal to 2 times p1. And since momentum becomes twice, you know kinetic energy is given by, kinetic energy is p square by 2m, it's directly proportional to momentum square. Momentum becomes twice, so kinetic energy becomes 4 times, so it increases by the factor of 4, right? This thing is clear, everyone? Okay, good. So then the next topic will start tomorrow, okay. So we'll stop here, and if you have not solved the test, solve it anytime, today, tomorrow, right, as per your convenience, okay. All right, so we'll stop here today, okay, bye.